Proline, 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 proline is one of the 20 amino acids that's used to make protein in the body. Now, just like every other amino acid, there's the center carbon to which everything else is attached. Now, in this case, there's going to be a carboxylic acid where you've got carbon with 2 oxygens and a hydrogen. It's also going to be attached to a nitrogen that's going to have 2 hydrogens attached to it. It's also going to be attached to a hydrogen on the back. And then this is where things get kind of funky for proline. The amino group, or the nitrogen that has the hydrogens attached to it, this is actually in a ring with the rest of the R group of proline. And so the rest of the R group of proline are these 4 carbons with the hydrogens attached to them. But as usual, because this nitrogen should only have 3 attachments, the fact that it has 4, there's 2 hydrogens as well as these 2 carbons, this is going to carry a +1 charge. So at the lowest pH, or the area in the environment where there are a whole lot of extra hydrogens around, the fully protonated form of proline is going to carry a +1 charge from this nitrogen. Now, as you go up in pH, eventually this is going to have more hydrogen than the rest of the environment, and it's going to have to give up some of its hydrogens to the environment to balance things out. The first hydrogen that's going to be lost from proline is going to always come from this carboxylic acid, and it's going to gain back its lone pair of electrons. This carboxylic acid is going to lose its hydrogen at a pH of about 2.0. At this point, we've got a negative charge on this oxygen, and we've got a positive charge on this nitrogen. So overall, these are going to balance out to a 0 charge, but there is an actual overall just neutral in this whole molecule. There are places where there are formal charges. So if you ever have formal charges on a molecule that balances out to a neutral or overall 0 molecule charge, this is called a zwitterion. Now, this molecule is going to look like this in its zwitterionic form until a pH of about 10.6, at which point this nitrogen is going to lose its extra hydrogen, gain back its lone pair. Now we've got a 0 charge here and a -1 here. So overall, it's going to have a -1 charge. But this happens only at a pH of over 10.6. So at physiologic pH, or what it looks like in the human body, a pH of about 7.4, the zwitterion, or where you have the nitrogen with the extra hydrogen still, but this oxygen has lost its hydrogen, this is the form that you're going to see in the human body, where it has a charge of 0. Now let's talk about the R group. The R group of proline, this nitrogen is supposed to be able to do hydrogen bonding within its backbone with other carboxylic acids from other amino acids. But because it's in this ring, it's not able to do that hydrogen bonding. So anytime you see proline within the amino acid structure of a protein, it's going to be creating a kink or some kind of bend within the secondary structure of the protein. So you can say proline is pro-lean, or in favor of leans, in favor of kinks. Proline is not an essential amino acid. You can use other things within the human body in order to make proline. You don't have to find it within your diet to be able to find it in the protein in your body.